Hello there. So in the last video we covered the setup for the browser Solidity interface for building, compiling and running your first smart contract on a local instance of Ethereum. And I think the next logical step is to show you how to use the application binary interface which you get from the compiler to actually invoke the functions on the smart contract code from the console window itself rather than the browser window. It becomes more intuitive at that point, and so I think that the browser is useful for compiling the code and giving you feedback on whether the code actually compiles, and also deploying the initial contract to the blockchain. But the console window is really where is probably the best place to to interact with the contract. So I'm going to start with so carry on from the last video where we had a simple adder contract, right? So we're going to it has a few functions. It has a name, which is a state variable. We talked about that a bit last time. It has a function to set the name, one to get the current name, one to add two numbers that you supply, just add them together and return the answer, one to add two numbers together that you supply, but also to rename the contract while you're at it, okay? And we'll explore that in a second. So first thing we have to do is we have to deploy. Let's deploy a new instance of this contract to the blockchain. I'm running geth. Just so you remember, let me just restart geth. It's exactly the same command from the last video. So I explained all the flags. You have to use these RPC flags in order to be able to connect to your browser, right? So I'm going to restart geth. Then I'm going to have to unlock my account, my default account with the passphrase, and then I'm going to start mining as well, right? So there we go. And remember, so what I have to do, I always have to disconnect and then reconnect to the Web3 provider when I restart geth, and then you've got localhost 8545 there, which is the same port as in the RPC flags when I restarted geth. So if I now try and create a new instance of this, so now we're waiting for the transaction to be mined. So hopefully this is kind of familiar from the previous video. Okay, so if I go down here, I should see that in my pending transactions. So yeah, we have a transaction here. Remember, the input for the new deployment of a new contract, the input field is the actual bytecode of the contract itself. I can see that has now come back. So now we'll see down here the pending transactions is empty. Keep doing that for some reason, and so that's great. And we saw last time. So we can supply two numbers and we can call add on them, right? And we get 11. And don't forget, and that doesn't cause any new transactions because it doesn't change the state, right? So if any of that's unclear from the last video, just please leave me a question in the comments. And then let's just run add and rename. So if we let's say add 45 and 64 and 63, but also rename the contract to Billy Bob, right? So because we're adding two numbers together, but we're also changing the name, which is a state variable, we require this to be mined, right? We don't care about the numbers because they're not state variables, but we do. This is a state changing function, so we have to wait. Down here again, we'll see there's one pending transaction here, and I don't know how long it's going to take to mine it. Shouldn't be very long. And there we go. So the block has been mined. So now we can see up here. We can see that this transaction here has successfully run. And if we now call the get name, that's now renamed, we can see that the name has successfully been changed to Billy Bob. So that's just a refresher a little bit on. So we've created this new contract. And we've shown that we can call all the functions from the console. But how do we get to the point where we can actually get a hold of this contract from the console? Because we like to use the console because that's the purer way of doing things. What we have to do is we have to go down here, and where it says interface, remember we talked about the application binary interface. So we have to copy or you might see it called as ABI. And I'm going to copy all of that, right? Just Control C, the whole thing. And in your window down here, we're going to do a JavaScript a variable assignment. So let's say var ABI equals, and then just paste what into the window, right? So now don't worry about the undefined thing there. That doesn't make any difference. So if we type ABI, we see it's formatted slightly nicer. This is the binary. This is the code that defines the interface so that I can call these methods, right? It's not part of the blockchain. The only thing that's on the blockchain is the actual. If we go back to is the actual bytecode, right, of the contract. This is external sort of metadata about the contract that enables clients who are interested in interacting with that contract to see, okay, well, what functions are available. It's like a catalog that says, oh, okay, let me see what's available in this contract. Okay, I can call get name, I can call add and rename, etc., etc. So the next thing we have to do is find the address at which the contract is sitting on the blockchain, right? So remember, the contract is everything inside the contract instance, right? Is everything inside this little box, and I can expand it and I can see, okay, here are the functions, here's the bytecode, etc., etc. Now, what I need to do when it says adder at this is the address of the contract, right? Now each contract, each specific deployment of a contract, each instance. So each contract is deployed to the blockchain, and it sits there at a particular address. Now, for those of you in Bitcoin, I'm going to go into more detail about this in a later video. Don't get confused in the sense that, well, how can, in Bitcoin, nothing exists at an address. Bitcoin is just a list of transactions on a blockchain, and there's no concept of state in the Bitcoin blockchain. But this is slightly different in Ethereum, and I'll go into it later videos. But so for now, just bear in mind that on each node, at a particular address, somewhere within the client, this is where this contract lives, right? Each contract has its own little space, and it's addressable and findable by this address within that space. If that sounds confusing, don't worry too much, because what I'm going to show you doesn't depend on your understanding this at this stage, right? So I'm going to copy that, and I'm going to create another variable called address, right? And I'm going to put quotes around it. And then that's my address, right? So if I do address, don't worry about the undefined again, right? So now what I'm going to do, I'm going to create a variable which is representing this contract, right? So this is a graphical representation of the contract in the browser, right, at this address. I'm going to create let's say a command line representation of that contract in the console. So if I do var, and then let's say adder, right, or let's call it adder1 equals, right, and then I'm going to do eth.contract. I'm going to do eth.contract, and I'm going to pass in my ABI variable, which I declared earlier, right, and then so that defines my contract, and then that defines let's say the template for the contract, and then which particular instance of the contract we're interested in looking at. It's the one at that particular address, right? So I'm going to do dot at, and then pass in the address variable, right? And now, so I have this is my representation. So now I have a variable called adder1, right, which is a variable in the console which I can now use, and I can actually invoke exactly the same methods, the same functions on the same contract from here as I can here, right? They're both the same contract. So let's give it a try. So if I try, for example, let's do one that says let's rename the contract. So first of all let's get the name of the contract to show that it's the same contract, right? So if we say adder1 dot get name, well, it's Billy Bob, right? So it's the same contract that we set get name here. If we do adder1 dot set name, and then let's call it Billie Jean, right? So this is interesting. I just tried to call set name, and the reason that I got an error here is because I need to set a variable as well called the default address, right? So I'm gonna copy this command, and don't worry, all these commands will be in the script in the video, right? So I'm just going to copy that in. Okay, so now I've set my default account, so now I can do set name Billie Jean. Well, I could if the account was unlocked. Can be a little bit of a pain. So I've unlocked the account now. Now hopefully now it should work. Set name Billie Jean. So now I've posted this set method in a transaction, which is now has to be mined into a block, right? Because we're changing this transaction. Sorry, we're changing the state of the contract. My apologies. So if we do eth.pending transactions, so we've got one pending transaction. Let's make sure the miner is running. So now the pending transactions is empty. So now if I call adder1.getName, right? Don't forget, adder1 is our variable which defines the contract, and we can call all the same functions that we defined here, right? Add, get name, add and rename. We'll show you in a second. Set name, right? So adder1.getName is now Billie Jean. So it's updated. It's updated locally, as in it's updated in our console. Let's see if it's updated up here, because remember it's the same contract. This browser is connecting to localhost 8545, so it's the same blockchain that we're looking at, and the same contract, right? Same address. We copied it from here. Don't forget. So if I do, let's just expand that again. If I do get name, and now it's changed to Billie Jean, right? So that's pretty cool. So what we've done, what we've shown you how to do, is to actually call these functions from the console, and from this point we can get a little bit more down and dirty with what's going on, and start using the browser a little bit less, right? So that was a quick intro into the application binary interface, how to get it from the console. Define and create a variable in your console window to define a contract that enables us to call methods on specific contracts that are in the blockchain. In the next video, I'm going to show you how to basically expand on this, but I'm going to start a few other nodes in the network and show you how this code that we're running on the contract is actually executing on all the nodes and reflected in the state of all the nodes. Okay, so thanks for watching, and I'll see you in the next one.